In the second part of section 7, we're going to look at straight lines and circles and where they intersect. If we solve the equations for the straight line and the circle simultaneously, we have three situations. The line can intersect the circle, the line can be a tangent, or the line cannot intersect the circle. And we can find this out from the discriminant. If the discriminant is positive, it intersects. If it's 0, it's a tangent. And if it's negative, they do not meet. In example 1, we need to find the geometric relationship between the straight line and the circle. If we write the equations down, we can substitute the equation for the straight line into the equation for the circle. If we now expand the bracket out and collect the terms for x together, we have a quadratic for x. So if we write down a, b and c, we can look at the discriminant. If we substitute the values in, we find the discriminant has the value 44, which is bigger than 0. So the discriminant is positive, and so the line and the circle intersect. Here is a typical exam question for you to try. Press pause, and once you've finished doing it, press play again to see the answers. Part A. We need to look at the intersection of the straight line and the circle. So we're going to solve these as simultaneous equations. We're going to substitute 2 into 1. And now we're going to expand the brackets and collect terms of x squared, x and constant together. Now we have the quadratic in x that we want in part A. In part B, we need to find the value of k so that the quadratic has equal roots. If we write down the value of a, b and c, we can use the fact that equal root means that the discriminant has to be equal to 0. So if we substitute the values in and then expand the brackets, we can collect the terms together and simplify to find that k is 0 or k is minus 8. In part C, we can say that equal roots or single repeated roots means that the line is a tangent to the circle. We'll finish with the key points from this section.